Right. Next topic, aromaticity. See, aromaticity is small topic in organic chemistry that is very useful in other chapters. Okay, aromaticity and nomenclature I will revise today. Okay, keep reading aromaticity. Concept of aromatic, non-aromatic, and anti-aromatic. Aromatic, anti-aromatic, aromatic, anti-aromatic, non-aromatic. This is a subtopic. Actually, we can discuss under benzene chapter, but you are writing the test, so you may get some questions on this. Okay, right. When we can say one compound as aromatic, one compound as anti-aromatic, and one compound as non-aromatic. Clear? Yeah. We have some rules. Okay. If we follow the rules, then we can predict which is aromatic, which is anti, and which is non-aromatic. Okay. Let us see that rules. For aromatic, anti-aromatic, and for non-aromatic. First condition or first rule or first principle. See, if one compound is cyclic, then only it may be aromatic, anti-aromatic, or non-aromatic. Okay, it should be cyclic. Okay, we cannot say open chain structure as aromatic, anti, non-aromatic. So first condition is compound should be cyclic. Cyclic. Here also for anti-aromatic also condition is same. Cyclic. First condition in anti-aromatic. First condition in non-aromatic. Cyclic, cyclic, cyclic. Okay. First condition is common for all. Right. Second condition. Compound should be planar. Compound should be planar. Planar means it contains sp2 and sp and sp2 hybridized carbons, right? All the atoms are present on the plane only. Planar. Okay, not out of the plane. Every atom is present on the plane only. Planar atoms. Okay, but how can we identify presence of sp and sp2 hybridized carbons in a molecule or ion? If you have all sp2 hybridized carbons, then that is said to be planar molecule. Very easy. Here also compound should be planar, and the same condition sp2 hybridized carbons should be present. But second condition in non-aromatic is different. Compound should be non-planar. Very important. Non-planar. Okay, so observe second condition is different in non-aromatic, right? Compound is non-planar means presence of sp3 carbon. If sp3 carbon means carbon surrounded by all single bonds is present, that is called as sp3 carbon. Okay, non-planar. So very easy to identify non-aromatic compounds. If you have sp3 hybridized carbon, then that is non-aromatic. Very easy to identify non-aromatic. No need to check any condition. If you observe single bonded carbon in any place of the molecule, any corner of the molecule, at least one sp3 hybridized carbon, total molecule is considered as a non-aromatic. Clear? Online students, are you getting? Are you following? Online students? Third one. Third one, conjugation should be present. Conjugation means alternative double bonds. Double bond which is connected to positive charge, double bond which is connected to negative charge, like this. See, alternative double bonds. Double bond, single bond, single bond, like this. Conjugation. Conjugation means presence of alternative double bonds, or double bond and a positive charge. If positive charge is connected to double bond, here also double bond, then also resonance is present. You know resonance concept. I given structural condition for resonance. Okay, when double bond is connected to an atom with A having positive, negative, double bond, radical, lone pair, same conditions. Conjugation. Here also third one, conjugation. Conjugation. Presence of conjugation. No conjugation. No conjugation. Conjugation is not present. Conjugation is not present in non-aromatic compounds. 2 times question came on this concept, aromatic and anti-aromatic, non-aromatic in NEET. Okay. And that was related to same example only. Clear? Right. Next. Continuation. What happened to this? Aromatic, anti and non. Continuation conditions, non-aromatic. See, look at these two. Here conjugation is present, here also conjugation is present. Then how can we differentiate which is anti and which is aromatic? We can differentiate non-aromatic easily by observing sp3 carbon. If sp3 carbon is present, then compound is non-aromatic. No need to worry about non-aromatic. But how can we differentiate aromatic and anti-aromatic? By using Haeckel's rule, 4n plus 2 pi electron rule, Haeckel's rule. So next point, compound should satisfy Haeckel's rule. Haeckel's rule, 4n plus 2 pi electron rule, called as Haeckel's rule. 4n plus 2 pi electron rule, where n is equal to 0, 1, 2, 3 and so on. 4n plus 2 pi electron rule, called as Haeckel's rule. I'll tell you what is Haeckel's rule, how can we find aromatic, anti-aromatic. Okay. In anti-aromatic, 4n pi electron rule, 4n pi electron rule, where n is equal to 1, 2, 3 and so on. Clear? For aromatic, Haeckel's rule. For anti-aromatic, 4n pi electron rule, where n is equal to 1, 2, 3 and so on. Here n is equal to 0, 1, 2, 3 and so on. Okay? Online students. Got it? Pranavi, Zui, Ketra, Madhiha, Kritika, Priyanka. Let us take some examples. Before starting examples, you have to remember few points, okay, while doing the questions. Note down that few points. What is carbocation hybridization? Means carbon with a positive charge. What is the hybridization? sp2. Hybridization of carbon with positive charge is sp2. Next, consider one negative charge. One negative charge is equal to 2 pi electrons. One negative charge has 2 pi electrons. One negative charge has 2 pi electrons. First note, second note and third note is take take always one lone pair of electron on oxygen and halogens, where X is equal to halogen, fluorine, chlorine, bromine and iodine. Fluorine, chlorine, bromine and iodine. Oxygen is having how many lone pair of electrons? Oxygen is having how many? 2 lone pairs. But while doing aromatic anti-aromatic questions, take only one lone pair into consideration. Halogen is having how many electron pairs? 3. Fluorine is having 3 lone pair of electrons. But while doing the questions related to aromatic anti-aromatic, take only one lone pair of electron. Okay. Remember these points. Okay, let us start. Example 1. Checking the following compounds, okay, which comes under aromatic or anti-aromatic. Very important model question. See, this is a small topic. See, in order to attempt one question from the carbonyl compounds, how much time you have to spend? You know carbonyl compounds chapter, preparation, properties, named reactions, everything clear? So you have to spend 4 hours time to learn, to practice, minimum 4 hours. Okay, minimum I am saying. But if you spend just half an hour to 45 minutes, this 30 to 45 minutes, then you can easily attempt one question. Okay. And let us see, this is aromatic or anti-aromatic. Let us check. See the procedure. First what we have to do? Write pi electrons. How many pi electrons are present here? How many pi bonds are present here? How many pi bonds are present here? 1 pi bond. 1 pi bond means how many pi electrons? 2. Pi electrons are 2. Pi electrons are 2. First we have to write the number of pi electrons in the given structure. We have to write the number of pi electrons in the given structure. Okay, we wrote number of pi electrons. Okay, next. What is Haeckel's rule? What is Haeckel's rule? 4n plus 2 pi electron rule. Checking Haeckel's rule. First write Haeckel's rule. 4n plus 2 pi electrons. 4n plus 2 pi electron. First we wrote number of pi electrons here. We recorded the data. 2. Number of pi electrons are 2. And according to Haeckel's rule, how many pi electrons we will get? Okay, according to Haeckel's rule. What is n value here? It starts with 0 or 1? 0. 0 or not. So first we have to check for 0. If n is equal to 0, check how many pi electrons you will get. If n is equal to 0, substitute 0 in place of n. 4 into 0 plus 2 pi electrons. How many pi electrons you are getting? 4 into 0, 0 plus 2. So you are getting 2 pi electrons. 2 pi electrons. Okay. You tell me, in the given species, how many pi electrons are present? 2. According to Haeckel's rule, how many pi electrons you got? 2. So number of electrons are matching or not? So this is aromatic. The compound which satisfies Haeckel's rule is said to be aromatic. Aromatic. You will understand if you do some more questions. First we have to write pi electrons in the given structure. Next we have to write number of electrons according to Haeckel's rule. How to write pi electrons according to Haeckel's rule? Start from 0 onwards. For any value of n, first you have to substitute n is equal to 0. After substituting n is equal to 0, you will get pi electrons or not. Check whether these electrons and these electrons same or not. If same, then aromatic. Clear? Now look at this. Another example. First tell me pi electrons. How many pi electrons are present here? Pi electrons 4. Pi electrons are 4. 4. We wrote pi electrons in the given structure. 2 pi bonds are present. 1, 2, 3, 4. 2 pi bonds are present. So 4 pi electrons are present. Now, according to Haeckel's rule, how many pi electrons are present? Checking Haeckel's rule. First, substitute n is equal to 0. If n is equal to 0, already we got here. How many pi electrons? 2. If n is equal to 0, 2 pi electrons are present. Once see, here 2 pi electrons, but in the given structure, how many pi electrons are present? 4. Is value matching? No, value is not matching. So, we have to go for n is equal to 1. For any value of n, 0, 1, 2, 3, if you get the same pi electrons like here, then compound is aromatic. Okay, first we will take one value. If you do not get same number of pi electrons, then we take another value of n. Okay, right. Another value. If n is equal to 1, substitute n is equal to 1. Tell me. N is equal to 1. 4 into 1 plus 2 pi electrons. How many you are getting? 6 pi electrons. Is value matching with original value? No. So this is not aromatic. For any value of n, you are not getting 4 pi electrons. Clear? So it is not aromatic compound. Not aromatic compound. Substitute n is equal to 1, n is equal to 0, n is equal to 1, 2, 3 and so on. But you have to get same value. Here how much we have? 4. So same value we should get. But 2 we got, 6 we got. So not aromatic. Value is crossed, yes or no? 2 after 6 coming directly, not 4. So this compound is not aromatic. Not aromatic. Now we have to check for anti-aromatic. Anti-aromatic. Checking anti-aromatic. What is anti-aromatic rule? 4n pi electron rule. 4n pi electron rule. What is n value here? 1, 2, 3, 4. In anti-aromatic rule, 1, 2, 3, 4 n value. In Haeckel's rule, 0, 1, 2, 3. Now substitute n is equal to 1. If n is equal to 1, then 4 into 1 pi electron. How many? 4 pi electrons. Value is matching or not? Here 4, here also 4. So this molecule is, this species is satisfying anti-aromatic rule. So this is anti-aromatic. AA stands for anti-aromatic. Got it now, all of you? Online students. Let us take another example. In 3 and 4, check which is aromatic and which is anti-aromatic. First of all, you tell me what is the rule 1 for aromatic? What is first rule? Cyclic? Second one? First one is planar or not? Planar or not? First one? Planar. All are sp2 only. In second one also all are sp2 only. Here during aromatic character, carbon with negative, carbon with positive should contain sp2 hybridization only. During which concept? Aromatic, anti-aromatic concept. Carbon with negative is sp2, carbon with positive also sp2 only. That is very, very important. See, you have to check all the points. Cyclic, cyclic, okay. Planar, planar. Why planar? Carbon with negative, sp2. You know already this is sp2, 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 sp2. All are sp2 only, na? sp2 means planar. Here carbon with positive, sp2. sp2 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 planar. If you do not check conditions in the sequence, then you may get wrong answer. That's why checking conditions in the sequence is important. First one is aromatic or not? Online students, what I said, consider negative charges. Once look at this, one negative charge has 2 pi electrons. One negative charge has 2 pi electrons. Here how many pi electrons are present? Negative charge is 2, 4, 5, 6. 2, 3, 4, 5, 6. For which value of n will get 6 pi electrons? Will we get 6 or not? Tell me. N is equal to 1. For n is equal to 1, then we will get a 6 pi electrons. Huckel's rule is satisfying or not? Very simple thing. After writing pi electrons, check Huckel's rule. Checking Huckel's rule means take n is equal to 0. Then you will get some pi electrons. Check that pi electrons and these pi electrons are same or not. If not, then take n is equal to 1. Then you will get some pi electrons. Check that pi electrons and these pi electrons same or not. In any case, if you get same pi electrons, then the compound is aromatic. See, if n is equal to 0, then we will get how many pi electrons? 2 pi electrons. If n is equal to 1, already we calculated. If n is equal to 1, how many pi electrons we will get? 6 pi electrons we will get. Okay. So, for n is equal to 1, it is satisfying Huckel's rule. So, this compound is aromatic. Aromatic. Note down its name also, cyclopentadienyl anion. Cyclopentadienyl anion. For important examples, I will give the names. Cyclopentadienyl. 2 double bonds are there. Dienyl anion. Cyclopentadienyl anion. What about second one? Means fourth question. Aromatic or not? Sorry. N is equal to 1, but pi electrons, first procedure, pi electrons, how many pi electrons we have? 1, 2, 3, 4, 5, 6 pi electrons. If n is equal to 1, then we will get a pi electrons are 6. So aromatic, its name is important. I said now 2 times question came in the NEET, this example only. So name is very, very important. Tropylium carbocation. Tropylium carbocation. 2 times question came in the NEET. Which of the following? Identify the aromatic compound from the given below. Tropylium carbocation. How many carbon atoms are present here? Tell me. Count, give numbering. Random numbering. 1, 2, 3, 4, 5, 6, 7. 7. 7 means hepta. Cyclohepta. How many double bonds are present? Cyclohepta. How many double bonds? 3 double bonds. Tri. Cyclohepta trienyl cation. But its common name is important. Questions came on the common name only. Tropylium carbocation. Cyclohepta trienyl cation. Satisfying 4n plus 2 pi electron rule, Huckel's rule. Are you getting, online students? Next question. To try this, I'll come. I'll bring that marker. This can be also represented like this. To try this, I'll bring the marker. Online students? No, first one is fifth one. Fifth one. Online students. Fifth one is no idea. Pragnika? What is the answer, Pragnika? Pragnika, are you there in the class? Pragnika. Pranavi? Priyanka? Madhiha, answer Ketara? Say answers. No. Don't say. Actually, this is aromatic or anti-aromatic. You have to say. The question is, which of the following is aromatic? Which of the following is entomeric? That is the question. You don't need to say n value. First one is aromatic. Why? Because 6 pi electrons are present, right? Okay.
Following that.
Okay. Once look at this one. What is this point? Tell me that is. Aromatic or anti-aromatic, that is. sp3 carbon. If sp3 carbon is present, undoubtedly that is non-aromatic. How to find sp3 carbon? sp3 carbon, what happens today? Okay, right? If you observe sp3 carbon, don't check any rule. Okay, don't do any procedure. Say directly that is a non-aromatic. What is the condition for non-aromatic? Presence of at least one sp3 carbon, non-aromatic. Got it? Second one. First of all, tell me, planar or not? Cyclic, it is cyclic, no doubt. Planar, yes. sp2, 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 sp2. All are sp2 carbon. This is also sp2 carbon. Okay? Right. How many pi electrons are present here? How many pi electrons are present here? Oxygen. What I said, when oxygen is present, what we have to do? Sir, hello? Sir, చెప్పండి. అయ్యో నేను పెట్టాను కదా సార్ మెసేజ్, ఆమె ఒకటే వాళ్ళ పేరెంట్. ఓకే, 9కి పెట్టాను సార్ నేను. ఏ వాళ్ళు అట్లా చేసుకుంటారులేండి వాళ్ళే. సరేలేండి, ఓకే సరే. ఇక్కడ నుంచి ఎమ్మటే పంపిస్తాను నేను, ఎమ్మటే పంపిస్తాను సార్ నేను. మీకు తొందరగా పంపించేస్తానండి. 8:30 అంటే మళ్ళీ నేను ఇంట్లో కొంచెం హడావుడి ఉంటుంది కదా. సర్లేండి, ఓకే సర్లేండి, ఓకే ఓకే సరే సర్లేండి, సరే సరే, ఓకే ఓకే. See, sixth example is aromatic because oxygen is present. I said to consider one lone pair on the oxygen. Okay, this lone pair only. Well, just a second, I'll explain this example. 1, 2, 3, 4, 4 pi electrons. Oxygen, consider one lone pair as a pi bond or pi electrons. Only one. This one. So 1, 2, 3, 4, 5, 6. Remember. On oxygen, consider one lone pair as a pi bond or one lone pair of electrons as pi electrons. One lone pair of electrons as pi electrons. Clear? Nitrogen also. If nitrogen is present, then also consider nitrogen lone pair as a pi electrons. If fluorine is present, then also same. Okay. So here 1, 2, 3, 4, 5, 6 pi electrons are present. So satisfying Huckel's rule. Don't consider second one. Don't consider second. That's why I given at the beginning one. Take always one lone pair of electrons on oxygen and halogen. Okay, as pi electrons. As pi electrons. Right. Oxygen is having two lone pairs, but consider only one lone pair. You will get slowly. Actually, a NEET level easy examples only will come, but we are discussing some difficult example. This example never came. Okay, this example never came. Easy examples only coming. You know, simple examples will come. Let us see one or two tough questions asked. And what about this one? How many pi electrons are present? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 means which rule it satisfies? Aromatic. For how much value of n? N is equal to 2. Yes, n is equal to 2. We will get 10 pi electrons. Clear? Okay. Right. Now one easy example for you. Do it fastly, all of you. Check aromatic or anti-aromatic or non-aromatic. Only NEET level I am giving. Then we can close. If we finish, we will close it. Make it first. 1, 2, 3, 4, 5 examples. First one answer. Online students. Online students. Non-aromatic. Why? Why non-aromatic, girls? Why non-aromatic? sp3 carbon is present. Very good. Single bonded carbon, sp3 carbon is present, so non-aromatic. Second one. sp3 is present or not? Non-aromatic. No need to check any rule or any condition. sp3 is present, non-aromatic. Non-aromatic, non-aromatic. 3. Online students. Anti-aromatic. 4 n pi electron rule it satisfies because 4 electrons are present, na? 4 n pi electron. Anti-aromatic. Next, this one. Anti-aromatic. Negative charge is considered as. One negative charge is considered as 2 pi electrons. So 2, 3, 4, 5, 6, 7, 8. 8 pi electrons means 4 n pi only. You check, you won't get 8 pi electrons with the Huckel's rule. Okay. Huckel's rule means 4n plus 2 pi electron rule. You won't get 8. With 4n pi you will get. If you substitute, see 4 and pi, 4 and pi electron, if you substitute n is equal to 2, 4 into 2, 8. But this rule is anti-aromatic, so this is anti-aromatic, AA, anti-aromatic. This one also anti-aromatic. So we completed one important concept: aromatic, anti-aromatic and non-aromatic. Clear? See the applications. One question will come directly, no doubt, no doubt. Probability is there. Okay, because 2 times question came, so probability is there. We completed, and again applications also important. Clear? Right. Next continuation. Before going to applications, write the stability order. Which is more stable compound, aromatic or anti-aromatic or non-aromatic? Stability order. Which is a more stable compound. Sometimes you will get question like this also. Aromatic compounds are more stable than non-aromatic. Non-aromatic. Non-aromatic compounds are more stable than anti-aromatic. Anti-aromatic. Aromatic is more stable than non. Which is least stable? Anti-aromatic is least stable. Least stable. Aromatic is more stable. More stable means energy is less or more? More stable means energy having less energy. Less energy. Stability and energy relation is inverse. If more is the stability, less is the energy. Stability order is important. Okay. For example, if you get 4 options, identify the stable compound. You have to check for aromatic compound. Which is aromatic compound? That is stable. Which is aromatic compound? That is stable. Identify the more stable compound. You will get one aromatic, one anti-aromatic, one non-aromatic. Then which is more stable? Aromatic. You know how to check aromatic? Yes or no? Right. Let us see some applications of concept of aromaticity. When we completed one model question, applications of aromatic, anti-aromatic. Applications. Predicting acidic nature. What is the relation between acidic nature and aromatic? Yes, relation is there. Actually, to predict acidic nature, we use general organic chemistry. Electron displacement effects, right? If minus I is present or minus M is present, then more acidic. We use that, right? But another concept also there, another phenomenon also there. Okay, by using that also we can predict acidic nature. See, I am giving 2 compounds to you. Which is more acidic? Then how to find acidic nature? There is no minus I group, there is no minus M group, then how to find? There is no OH. Generally alcohols are more acidic. Alcohols are acidic because hydrogen is present on the oxygen. So you can say, sir, alcohols are acidic. Why? Because hydrogen is present on the oxygen. Carboxylic acids are acidic. Why? Because hydrogen is present on the oxygen. Clear? But how to predict acidic nature? Acid means, according to Arrhenius theory, what is acid? The substance which gives H plus ion is called as acid. Now do one thing. Here 2 hydrogens we have, right? Okay. Remove H plus, sir. Remove H plus. So you are removing only hydrogen. This will accumulate as a negative charge. Right? Let us consider it will act as acid. The substance which gives H plus is called as acid. Let us consider it acts as acid and losing H plus ion, and we are writing conjugate base. Here also hydrogen is coming out and this bond is accumulated as negative charge. Possibility is there to act as acid. Okay. Now, in which release of H plus is easy? That is the question. You observe the stability of conjugate base. This is aromatic or anti-aromatic? First box is aromatic or anti-aromatic? First box is anti-aromatic or aromatic? You know already. Aromatic. 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 Second box is anti-aromatic. Second box is anti-aromatic. But which is more stable, aromatic or anti-aromatic? What is stability order? Aromatic is more stable. So loss of H plus from this compound is feasible or possible. Why? After losing, it is converting into stable aromatic. Conjugate base is aromatic. So loss of H plus is very easy. So this compound act as acid. Arrange the following compounds in the increasing order of acidic nature, or which of the following acts as acid? This is good acid because its conjugate base is aromatic and more stable. Its conjugate base is anti-aromatic. Anti-aromatic compounds are less stable. So this is not feasible. So release of H plus is not possible here. Got it? All of you. In tomorrow's exam, I am only saying one question will come because you will do practice. Okay, at least one concept you will prepare perfectly. Okay, and one important point, I sent solutions also for last exam. Did you write error notes? Did you write error notes, all of you? I'll check tomorrow. After every exam, you have to maintain one error notes. Write the solutions. It will give practice to you. Okay. I'll check tomorrow error notes. One application is our acidic nature. Okay, based on the concept of aromaticity. Next, reactivity. High level questions. When question paper is standard, then you will get these type of questions. Okay. Reactivity of alkyl halides. RX. Reactivity of alkyl halides towards SN1. Reactivity of alkyl halides towards SN1. See, in SN1 reaction, which alkyl halide readily participates? 1 degree, 2 degree, 3 degree. Which alkyl halide participates readily? Online students. What is order of reactivity? 3 degree. 3 degree alkyl halides participates in SN1 readily. Okay, good. Another concept of predicting reactivity is aromaticity, anti-aromatic concept. We know one concept, degree based on the stability, plus m, minus m. Here, generally, what is the criteria under factors affecting SN1 reaction I given in the reaction mechanism? The alkyl halide which forms a stable carbocation readily participate in SN1. And you know what is stable carbocation? For new students also I explained about carbocation stability. Here, the alkyl halide which forms a stable carbocation that readily participates in SN1. That is the concept. Clear? Okay, based on that concept we can predict. Another concept is, look at this question only. Which of the following readily participate in SN1? Which of the following readily participates in SN1? Same concept only, but type of question is different. Concept is same, type of question is different. Remember this point, the alkyl halide which forms stable carbocation readily participate in SN1. And what is step 1 in SN1? Very good, formation of carbocation. SN1, step 1 is formation of carbocation. You are going to write the test tomorrow on entire organic chemistry, including all these things. Okay. Step 1 is formation of carbocation. Remove halogen along with the bond. That is only in SN1 I explained already. Positive charge. Step 1 is formation of carbocation. Here also remove halogen along with bond. Step 1 is formation of carbocation. Right? Which is stable carbocation? Between these two, which is stable carbocation? Second one or first one? Which is aromatic and which is anti-aromatic? First one is anti-aromatic. First one is anti-aromatic. Why? How many pi electrons are present? 4 pi electrons are present. Anti-aromatic. See the link. Okay, that's why I explained aromatic, and because in grand tests or in coming tests you will get questions like this, standard questions. Okay, this is aromatic because it is having only 2 pi electrons. For n is equal to 0, then we will get 2 pi electrons. Clear? This is aromatic. Aromatic. Now you tell me which is stable. What is the stability order? Aromatic, anti and non. Which is more stable? Aromatic. Aromatic after non-aromatic. And least is anti-aromatic. So this is anti-aromatic now. So least stable carbocation. But what is the statement? The alkyl halide which forms stable carbocation, then it readily participates in SN1. Between these two, which is stable? This is stable. Why this is stable? Because it is having aromatic character. So this is stable. It is coming from this alkyl halide. So this will readily participate in SN1. This is different criteria. Clear? Now you tell me what we did here. What we did here? We removed halogen as negative charge or not? Cl negative. Here also what we did? Removed halogen. So what we will get? Cl negative. Cl negative. You know, when AgCl precipitate formation takes place, when you have Ag and when you have Cl, then AgCl precipitation formation takes place. See, we are adding AgNO3 to this compound and AgNO3 to this compound. AgNO3, silver nitrate we are adding. AgNO3, here also we are adding Ag. This is another model question. Which of the following compound readily gives precipitate with AgNO3? Very important model question. Concept is same concept. But pattern is different, model is different. Clear? Which of the following alkyl halide readily gives precipitate with AgNO3? See, which is forming stable carbocation? This is forming stable carbocation. Okay, here release of Cl negative is easy. This Cl negative reacts with Ag plus to form AgCl. So very simple thing. Remember, the alkyl halide which forms a stable carbocation readily forms precipitate with AgNO3 or readily forms AgCl precipitate. Concept is same. Why this is stable? Because aromatic. That's why it readily forms AgCl precipitate. The alkyl halide which can produce stable carbocation will form AgCl precipitate. You know stability orders. Here you know GOC, right? Resonance, inductive, effective stabilities, you know. Just we are expanding, you are linking that general organic to another concept. Precipitation concept, reactivity concept. Clear? So we started aromatic, anti-aromatic, and we completed applications and we linked that aromatic concept to some other different model questions. Clear? This is subtopic actually. One subtopic this is. Okay? Prepare for tomorrow's exam. I am closing because few students were not attending. Okay. Prepare properly for exam. Bye.